feels like a mind. It sounds like it understands you. It writes poetry, solves math problems, and holds conversations that feel human. But here's the truth they don't want you to think about. It's not a mind. It's a probability engine. Nothing more. This technology, the large language model, doesn't know anything. It doesn't understand your question. It doesn't have opinions. What it does is make predictions. Incredibly complex, stunningly accurate predictions about which word should come next. That's the entire trick. And once you understand that, everything else makes sense. Today, we're going to open the black box. We'll look at what's actually happening inside these systems, not the marketing version, not the science fiction version, but the engineering reality. By the end, you'll understand exactly what an LLM can do, what it cannot do, and how to use it without getting fooled. Think of it this way. An LLM is a compass in a dense fog. It provides a powerful sense of direction, pointing towards likely answers based on the terrain it was trained on. But it is not proof of the ground beneath your feet. That metaphor will guide everything we discuss today. Let's start with the fundamental operation. When you type a prompt into ChatGPT, Claude, or any other chatbot, here's what happens. The system takes your text, converts it into a mathematical representation, processes it through billions of calculations, and outputs a probability distribution, a ranked list of every possible next word with a percentage chance assigned to each one. Then it picks one. That's it. That's the entire magic trick. But to understand how this works, you have to forget the idea of words. The machine doesn't see text like we do. It sees tokens, text chopped into pieces. Sometimes a token is a whole word. Sometimes it's part of a word. Sometimes it's just punctuation. This tokenization is a simple but revolutionary idea. It gives the model flexibility to handle any language, any text, any input. Now, here's where the breakthrough happens. In 2017, a team at Google published a paper titled "Attention is All You Need." It introduced something called the transformer architecture. Before this, language models process text one word at a time in sequence. The transformer changed everything. It gave the model the ability to look at the entire context all at once and decide which tokens matter most for predicting the next one. This is called the attention mechanism. Imagine you're reading a sentence, and your brain automatically highlights the most relevant words for understanding the meaning. That's what attention does mathematically. It creates weighted connections between every token in the input, allowing the model to understand relationships across long distances. The word "it" at the end of a paragraph can now connect back to a noun from the beginning. So how does the model learn? This is where scale becomes almost incomprehensible. During pre-training, you feed this machine nearly the entire internet. Books, articles, websites, code repositories, forum discussions, trillions of words. And for every sequence of text, the model makes a prediction about the next token, compares it to the actual next token, calculates its error, and adjusts its internal parameters. This process is called backpropagation. Predict, error, update. Billions of times. Over weeks or months of continuous computation. What emerges from this process is not understanding. It's pattern recognition at an unprecedented scale. The model learns that certain words tend to follow other words. It learns grammar, facts, writing styles, coding conventions, not because it was taught these things explicitly, but because they're patterns in the data. It's a statistical mirror of human language, reflecting back what it has seen most often. When you ask it a question, it's not giving you the answer. It's sampling from a probability distribution. There's a setting called temperature that controls how this sampling works. Low temperature means the model picks the most likely tokens, safe, predictable responses. High temperature means it takes more risks, choosing less probable tokens. This is why you can ask the same question twice and get different answers. But here's a question. If the model just predicts the next token, why does it try to be helpful? Why does it answer questions instead of just continuing your text like an autocomplete? That's a separate, crucial step called alignment. After pre-training, the model goes through additional training where humans guide it. They show it examples of helpful responses, rate different outputs, and the model learns to produce answers that humans prefer. This is reinforcement learning from human feedback, RLHF. It's behavior shaping on a massive scale. This alignment process is why chatbots feel so different from raw language models. The base model might continue your text in any direction, helpful, harmful, or nonsensical. The aligned model has been trained to be helpful, harmless, and honest. But here's the critical point. This alignment is a layer on top. It doesn't change the fundamental nature of the system. Underneath, it's still just predicting tokens. And this is where the reality check comes in. Because the model is only ever predicting the most probable next token, it can be confidently wrong. It generates plausible-sounding nonsense, what we call hallucinations. It might cite a paper that doesn't exist, invent statistics, or describe historical events that never happened. And it does this with the same confident tone it uses for accurate information. Why? Because confidence is a pattern in the training data. Authoritative text sounds authoritative. The model learned to sound right, not to be right. This isn't a bug. It's a fundamental feature of how these systems work. The model has no concept of truth. It has no way to verify facts against reality. Cannot check its own work. It simply generates the most statistically likely continuation of your prompt. Sometimes that continuation is accurate because accurate information appears frequently in the training data. Sometimes it's completely fabricated because the pattern of confident-sounding text is stronger than the pattern of factual accuracy. Remember our metaphor, the compass in the fog. The compass points in a direction based on the magnetic field it was calibrated to. But if the terrain has changed, if there are local anomalies, if you're in unfamiliar territory, the compass doesn't know. It just points. Your job is to verify the ground before you step. So how do we use this tool safely? 3 rules. First and most important, verify everything. If an LLM provides a fact, a figure, a citation, a date, or a piece of code, assume it's a plausible hallucination until you prove otherwise. Don't trust, verify. Check the source. Run the code. Look up the reference. This isn't paranoia. It's the only rational response to a system that cannot distinguish between truth and plausible fiction. Second, constrain the model. Don't ask it open-ended questions about complex topics and expect reliable answers. Instead, provide it with the text, the data, the document you want it to work with. Give it a specific task. Summarize this, extract these fields, reformat this data. When you constrain the input, you constrain the possible outputs. The model becomes a tool for analysis rather than a source of truth. That's where it excels. Third, use it as a tool, not a teammate. It's a powerful brainstorming partner, a fantastic first draft generator, an incredible summarizer and translator. But it is not a co-author. It is not responsible for the final output. You are. Every claim it makes needs your verification. Every decision it suggests needs your judgment. The moment you treat it as an autonomous agent with reliable knowledge, you've made a category error that will eventually cost you. These rules aren't about limiting the technology. They're about understanding its nature. The model is designed to generate the most probable continuation of a sequence. That is its only goal. It has no concept of truth, accuracy, or intent. It only has patterns. And patterns can be incredibly useful if you know what they are and what they're not. So what is this technology? It's not magic. It's not a mind. It's not artificial general intelligence. It's a new interface to knowledge, a powerful, flawed, and revolutionary way to access, manipulate, and generate information. A tool that offers direction, not proof. And like any powerful tool, its value depends entirely on the skill and judgment of the person using it. Compass in a fog. Useful for direction, not proof of terrain. And it's only reliable if you verify.